Hello CS111 students. This is the task explainer video for task 1 of problem set 2, the time profiler deluxe task. And as you can see on my screen, I have the task open already. I'm going to walk you through whatever is in these instructions. You do not have to watch this video. I'm just walking through what's in the instructions. You can read them on your own. This video is if you want a different format to help you engage better or understand the material better, if that helps. But I'm not really going to introduce any material that's not already in this description. So, what is up with this task? Has a name that's similar to the time profiler from last problem set. Well, it turns out the whole task is similar as well. The goal of this task is to give you a chance to practice using functions and parameters, including defining your own functions and using them with each other. And to do that, instead of giving you a new problem to solve, we're just asking you to solve the same problem as before, with a few bells and whistles extra, using functions instead of just using raw code. So we're going to be doing the same thing. There are a few minor changes and one major change. First, there's no longer any blank lines between the input prompts, like you saw in the examples of the output from task 3 for problem set 1. When you go to the end of this problem set, and we'll get there at the end of this video, there's some example outputs and you'll see what I mean. But basically, the input lines happen one after each other without blank lines in between. There's still a blank line between all of those inputs and all of the outputs. Another minor change is that the prompt for the number of classes you're taking per semester, before we said only integers are acceptable here. And now we're saying, actually, you could be taking a floating point number of classes, like 2.5 classes if you're taking a half class. So we just allow a floating point number there. And then the third change, which is the big one, is the output is getting fancier. Instead of just printing how many hours each thing took, we're going to print a line of characters, right? Repeated characters that show us visually the comparison between the amount of time we're spending per week on these different categories. To do that, we're also going to have to do some indentation to line things up so that those bars all start in the same place. And that's the little extra bit of challenge we've added to this problem. Other than that, you'll be able to recycle a lot of your old code if you want. So, the big change is behind the scenes, right? It's going to do almost the same thing as your other program, but it's going to do it in a different way. It's going to do it using functions. So we have a lot of procedure requirements, right? Requirements about how your code is written, not about what it does, even though the requirements about what it does are fairly similar to last week. If I open up the rubric real quick, just to show you, and you should look through this rubric, even though it's long, to see all the requirements it has. It says, yeah, define this function, call this function and this function within the definition. And it has a whole lot of this stuff because there's a lot of specific functions we want you to define. I'm going to go through the description of those things here, but you should also check out the rubric for yourself. So, in terms of these procedure requirements, what are the functions you have to define? Well, there's 3 categories of functions. The first one is functions for getting input from the user. The second one is functions for building out the messages that we're going to return. And then the third one is functions, the main function, the thing that sort of ties it all together and puts all those functions to use to produce the overall experience. Our first category of functions includes ask name, ask class hours, ask category name, ask extra hours, and ask sleep hours. Most of these functions take no parameters at all, and instead they use input to gather information from the user, right, rather than us, the programmer, supplying a parameter value. The exception is ask extra hours, right? When you ask for the category name in the output, you then use that category name in the question where you're asking, hey, how many hours do you spend per week on that thing? And so the ask extra hours function is going to have one parameter, a string, which is the category name, and it's going to use that in constructing the question that it asks. All of these functions, so ask name and ask category name, those two are going to return strings. All of the rest of them are going to return integer floating point values, numbers, which are expressed in terms of hours per week. So for example, ask sleep hours, it asks the user how many hours they sleep per night. but it returns a value of how many hours they sleep per week by just multiplying by 7, right? 7 days a week. So some of these functions are going to do a little bit of math on top of just asking the user for input and converting that input, when appropriate, to numbers. All of these functions are fruitful. They all return results that can then be used further by the program. They do use input, so they create some output because input creates a prompt, but none of them are actually using print to print any output. Okay, once you've defined those 5 functions, and again, take a look at the rubric for some of the details, your program needs 3 functions to assemble the messages it's going to display to the user. So we have a bunch of inputs that we've gathered, we've stored them in variables, we have different number of class hours and sleep hours, right? We're ready to print some stuff out. We're going to define functions that return strings in order to create messages, and then we're going to take those messages and print them out in the end. So, category hours message is a function that takes 2 parameters, a category name and a number of hours per week. It's going to take those 2 parameters and create a message that combines them. It rounds the number of hours per week to 2 decimal places. It combines it with the name of the category and then the word hours. And so, for example, if the arguments were the string class and the number 35.159, the output would be 35.16 class hours, right? We've rounded that off. The indent message function, the next one in our functions for building messages, is going to take 2 parameters, a message, which is a string, and a target length, which is a number of characters that we want the string to have in length. What it's going to do is it's going to return a new string where spaces have been included in that new string to make the whole length of the new string equal to the target length. So if we have a short message and a long target length, the message is going to be all the way on the right with a bunch of spaces beforehand. Now, just for the core goals, you can assume that the target length is always going to be at least as long or longer than the string that is being indented. But if you want to complete the extra goals, you have to handle the case where the target length might be shorter. What your function should do in that case is just return the original message string without any modifications. Not try to chop it down to be shorter or anything like that. That's too complicated. But you'll still have to add a little bit of code to make sure you don't crash in that case. Okay, report line is a function that takes 3 parameters, and this is the last of our message producing functions. It's going to take an indented message as the first parameter, a number of hours per week, a floating point number, and then a letter, which is a string that just has 1 character in it. It's going to use that last letter to build a bar to represent visually how many hours per week the number is. And it's going to tack that bar onto the end of the message that it got as the first argument. And there's an example here of what that will look like, which you can go through. You can also think about how this function is fitting into the examples we'll see later in terms of what that will look like. So once we've written these functions, and they all do what they're supposed to do, right, according to these descriptions and the contracts that are specified by the rubric, we're going to write a final function, a function called main that basically puts all of that stuff together and coordinates it to produce the overall behavior of the program. So before, we just wrote code in our file. When we clicked run, it all ran. This time we're going to write code in a function called main. We are going to call that function when we run the file, but somebody else could call it twice if they wanted, or something like that. So our code is sort of organized into a function. The main function has examples, which I'll get to in a second, of what the behavior should look like in terms of inputs and outputs. It's up to you to figure out how the different functions that we've already defined in terms of the other requirements can be put together to achieve that. The one note that you'll need is that the main function always uses the same letters for each category in the bars that it displays. It uses C for class time, X for the extra category, S for sleep, and F for free time. The other note here is you must use the exact function and parameter names specified by the rubric. Otherwise, you're not going to be achieving those core goals. So for example, in the rubric, it says, here, okay, report line. You must define a function called report line. The parameter names have to be message, hours per week, and letter. Stick to exactly this format. Otherwise, our grader is going to look at your code and say, I don't see a function with this name and these parameters. I guess you didn't do it, right? Okay. So once you've defined main, here's the behavior you should be able to see. As before, blue values here are indicating what you have to type in to get this output, and the black is what the program prints itself. You can see that the prompts here are the same prompts as we used last week. It's just that they're not spaced apart anymore. There's this one blank line, and then we get the output. And here's the big difference. So before, we would have just printed sort of like this part of the message is up to the colons, and it would have all been left aligned, right? We're just printing each string. Now we're adding spaces into these strings so that the colons line up, and the bars, then we can compare them to see like, ooh, well, this person spends more time in class, or about the same amount of time in class as they have free time, for example. There's 3 example outputs here. You can use these to test your program and see if it's working. And as before, we have a link down here at the very bottom to a difference checker website if you want to plug these strings into that website and then take your program output and plug it in too to see if there's any minor differences. But if you want to get all the extra goals, you're going to have to think beyond these 3 examples to, well, how should the program behave in other possible cases? Okay. There's a note here that I've sort of already covered, right? You have to figure out how to use these other functions we've already defined to produce this behavior. But the spaces here, right, are indentation that's probably introduced by this indent message function. The last part here about testing. So you should test every function that you write individually. And you're going to have to come up with what the inputs and outputs should be for that test. But you can base them off of what is happening in these examples. It's also kind of nice that we can test those functions independently, make sure that they work, and we don't just have to test everything at once, right? If we're sure that parts A, B, C work, when we're testing part D, it's simpler. The other note here for testing, though, and this applies sort of from here going forward, is that you may only call functions inside of other function definitions. The starter code we supplied already has a function called the main function. And so that means that when you run your code, it'll call your main function. If you want to test your other functions, if you do that in your file, make sure you delete those tests before you submit your code. Or you can always test using the shell, and then the tests that you're doing don't appear in your file. But don't leave unattended function calls wandering around your file that aren't part of the code you're writing for specific functions. That's going to mess with our testing procedures. So that's it for my video for this task. There will be videos for the other tasks as well. Thank you for following along.